Module 3, Lesson 13. Today we're going to spend some more time looking at inequalities. And we're going to be writing some inequality statements to start out with. And so let's get started. In this opening exercise, we're going to be writing inequality statements. Tariq is trying to save $265.49 to buy a new tablet. Right now, he has $40 and he can save $38 a week from his allowance. Write and evaluate an expression to represent the amount of money that he has saved after 2 weeks, 3 weeks, 4 weeks. So if we start out with our expression, well, we know that he has 40. He can save $38 a week, but in this case, we're trying to figure out how much did he save after 2 weeks. So this is 40. 38 times 2 is 76. 40 plus 76 is 116. So how about after 3 weeks? So we're going to continue with this pattern to go ahead and solve for this. But instead of 2, we're going to replace that with 3. So we've got 40 plus and 38 times 3 is 114. 114 plus 40 is 154. Again, we're going to do this with 4 weeks. The only difference is instead of 2 or 3, we're making this 4. And so that's 40 plus 38 times 5 is 152. 152 plus 40 is 192. After 5 weeks, right, 38 times 5. 40 plus 38 times 5, so plus, what is that? 190. And then if we add these together, we get 230. After 6 weeks, we've got 40 plus 38 times 6, that's 8, regroup, $228. So if we add those together, we get 268. And if we turn to the next page, we've got 2 more. We're going to do week 7 and week 8, okay? And then we're going to answer some of these questions to figure out. So 7 weeks, that's going to be 40 plus 38 times 7. And 38 times 7, that's 6 and 5, 21. That's 26. So 266 plus 40 is going to be 306. And our last one here is 40 plus 38 times 8. And 40 plus, let's see, 38 times 8, that's 64. 8 is 24 plus 6 is 30. So 304 plus 40 is going to be 344. So remember, originally, right, we needed to find out, let's go back up here. We need to find out how long it was going to take Tariq to save $265.49. So if we look at each of the weeks, right, and let me highlight, here's week 1, week 2, week 3, week 4, week 4, week 5, week 6. Looks like in week 6, he's got just enough. And of course, in week 7, he's got plenty. And in week 8, he has plenty. So the question here is, when will Tariq have enough money to buy the tablet? He will have enough money by week 6. Okay? Write an inequality that will generalize the problem, right? Because, you know, he might want to save a little bit more. Who knows? But this way we can figure out with any weeks, right? We could just populate it. So basically what we just did was we said, okay, he already has $40. We know that he can save 38 a week, but this time instead of putting an actual number in there, we're going to put a variable and we're going to use W for weeks, okay? W is equal to weeks to save, okay? But this is not an inequality yet. It's still an expression. Now, he can save enough money that's exactly the amount, right? So we could say that what he has to save has to be greater than, but it can also be equal to $265.49. There is our inequality. All right, let's look at example 1. Evaluating inequalities and finding a solution. The sum of two consecutive odd integers is more than negative 12. Write several true numerical inequality expressions. Feel free to come up with your own, but I'm going to give you a couple of examples, okay? So remember, these are two consecutive, which means they're right after each other, and they're odd integers. So that's our 1, 3, 5, 7, 9. So if I think about 1 plus 3, right, and I'm thinking about these have to be more than negative 12. Well, 1 plus 3 has to be greater than negative 12. Well, 1 plus 3 is 4. 4 is, in fact, greater than negative 12. All right, how about if we just go up a bit and choose 3 plus 5, right, because it's the sum, is greater than negative 12. Well, 3 plus 5 is 8, and 8 is, in fact, greater than negative 12. Now, I want to give an example of what about negative numbers? Would these statements still be true? Let's try negative 1 plus negative 3, greater than negative 12. So negative 1 plus negative 3 is negative 4, and this is, in fact, still a true statement. Negative 4 is, in fact, greater than negative 12. Let's try what happens if one's a positive and one's a negative. Let's say negative 1 plus a positive 3. Is that greater than negative 12? So if we have a negative 1 and we add 3, we're going to end up at positive 2. And positive 2 is, in fact, greater than negative 12. Okay? Now, the sum of two consecutive odd integers is more than negative 12, right? What is the smallest value that will make this statement true? Write an inequality that can be used to find the smallest value that will make the statement true. Okay, so we're going to say that x is equal to an integer. Integer, there we go. And then we're going to say that, well, 2x plus 1, because remember they have to be odd, right? So this is going to be the next odd integer. And then 2x plus 3 would be equal to our next odd integer. So let's put this in the form of an inequality. We can say that 2x, and we only need 2x plus 1 plus 2x plus 3, because we only need two consecutive integers. And we're going to say, because again, the sum of two consecutive odd integers is more than negative 12. So we're going to say it has to be greater than, okay, not equal to, negative 12. And so whatever integers we put into this, right, this should help us come out with the smallest number. All right. Let's go to B. Use if-then moves to solve inequalities written in part A. Identify where zeros and ones were made using the if-then moves. So remember our if-then moves from equations. We're talking about the same thing. We're talking about distributive. We're talking about commutative property. We're talking about combining like terms. We're talking about the additive and multiplicative inverses. Those are in if-then moves, just as a review. So we're going to take our original, the one we just created, which was 2x plus 1 plus 2x plus 3 is greater than negative 12. So the first thing we're going to do is combine like terms. Okay, so I've got two 2x's. That's going to be 4x plus 1 plus 3 is 4 is greater than negative 12. Now that I have my inequality with all terms like terms combined, I'm going to start by using the additive inverse, which would be to subtract 4 from both sides. So I end up here with 4x is greater than negative 12 minus 4 is the same as saying negative 12 plus a negative 4, which is going to be negative 16. Now, to get rid of that 4 on the opposite side, we're going to use the multiplicative inverse. Okay? We're going to divide both sides by 4. X is greater than, and negative 6 divided by a positive 4, that's going to be a negative because they're opposites, but 16 divided by 4 is 4. So x, this tells us the smallest value, right? This tells us that the smallest value could be x has to be greater than negative 4. And there we go. So what is the smallest value that will make this statement true, right? So what we're going to do is we're going to substitute, because we need to find the odd integer, right? To find the odd integer, we're going to substitute negative 4, okay, for x. So we've got 2x plus 1. If we substitute 2 times negative 4 plus 1, 2 times negative 4 is negative 8 plus 1. Negative 8 plus 1 is negative 7. So the value to make this original inequality true, the one with the greatest, okay, let me try that again. The values that make the original inequality true are greater than negative 7, right? Therefore, the smallest, right, would be negative 5 and negative 3. So let's write that down. The values that make the original oops, I spelled inequality wrong. I already started on the wrong. What's going on? I want to undo. There we go. The original inequality true are greater than negative 7. Therefore, I don't know if you guys remember this little triangle I taught you. Therefore, the smallest are negative 5 and negative 3. All right, let's go do a couple exercises. Connor went to the country fair with $22.50 in his pocket. He bought a hot dog and a drink for $3.75 and then wanted to spend the rest of his money on ride tickets, which cost $1.25 each. First, we're going to write an inequality, right, that represents the total spent, where R is the number of tickets purchased. So if he purchased the tickets, they're each $1.25, so I'm going to put $1.25 R plus the $3.75 for his drink. Now, he only has $22.50, so he has to spend less or equal to that. So this has to be less than or equal to $22.50. There is our inequality. So Connor wants to use his inequality to determine whether he can purchase 10 tickets. So we're going to use substitution. So we're going to take the inequality we just created, but instead of putting R, we're going to replace it with 10. So we've got 1.25 times 10 plus $3.75 is less than or equal to $22.50. Now we're going to solve this by subtracting $3.75 from both sides. That creates 0. Subtracting $3.75 from the other side. On this side, we end up with 1.25 times 10 is less than or equal to, and in this case, 2250 minus 375 is going to give us 16, wait, what is that? 22, so that's 5, and we've got, oh, I'm sorry. I am doing this. I am trying to solve an inequality, but we already have it. I just did that wrong. I apologize. So this is going to give me, I'm going to do 1.25 times 10, which gives me 12.5 plus 3.75. I knew something wasn't right. I just couldn't figure it out at the moment. All right, so now that we've got that, we're going to add on this side, and we end up with $16.25 is less than or equal to $22.50. So yes, he can purchase, purchase 10 tickets. He has enough money. All right, and that's that one. Let's go to the next page here. What is the maximum number of tickets he can buy based upon the given information? So this is what I was trying to do earlier. I was ahead of myself. So the way that we find out what the maximum number of tickets is for us to take our original inequality and to solve for R. That's going to tell us the maximum amount. So this is where we're going to subtract 375 from both sides. And we end up with 125R is less than or equal to, and 2250 minus 375 is 1875. And then we're going to use the multiplicative inverse and divide both sides by $1.25. This leaves us with R less than or equal to 15. So the max amount of tickets he can buy is 15. All right. Last one. Write and solve an inequality statement to represent the following problem. On a particular airline, checked bags can weigh no more than 50 pounds. Sally packed 32 pounds of clothes, 5 identical gifts in a suitcase that weigh 8 pounds. And we're going to write an inequality to represent this situation. So here we go. We know that she can't check more than 50 pounds, okay? So whatever is on the other side of this inequality, it has to be that 50 is greater than or equal to, and we've got 32 because that's how many pounds of clothes she has. We also know that she has 5 gifts, but we don't know what each one is. So that's 5 times X. And we do know that they're 8 pounds, right? We know that they're total of 8 pounds, but we don't know what 5X is. So now we can go ahead and solve to find out, well, how much does each gift weigh? So we're going to start by combining like terms. So we've got 50 is greater than or equal to 40 plus 5X. Now we're going to subtract 40 from both sides. We end up with 10. 10 is greater than or equal to 5X. Divide both sides by 5. We end up with 2 is greater than or equal to X. So each gift weighs 2 pounds